Programming Throwdown, episode 94. Search at Etsy. Take it away, Jason.
Hey everybody, we have a pretty awesome episode here. We have an interview episode with Liangjie, who's Director of Engineering, Data Science, and Machine Learning at Etsy. And Liangjie's going to tell us all about kind of how search works. When you type a search query into that box, what actually happens under the hood. Liangjie, why don't you talk about, introduce yourself and talk about, kind of what led you to the path that took you to where you are now.
Yeah, sure. First of all, thank you for having me here. So I'm Liangjie Hong. I'm the Director of Engineering, Data Science, and Machine Learning here at Etsy. So I'm managing the organization of applying machine learning to a lot of different products here at Etsy. So currently we have a mix of data scientists and machine learning engineer here at Etsy, working on problems like search, which is kind of the major topic we are going to talk about today, as well as other domains like recommendations, advertising as well. We have engineers present in both of our headquarters New York City office as well as San Francisco office, and we are hiring and growing teams there as well. Before coming to Etsy in 2016, I worked in Yahoo Research in California. So I first joined as a research scientist and later as a senior research scientist and later promoted to managing a group of researchers focusing on personalization recommendation as well as some of the mobile search innovations back then. So that is a path that led me to figuring out how to best fulfill this, providing the most relevant to users, the most relevant result to users, and then find Etsy is a place that I can grow the team and grow my career. So that's pretty much of the path.
Cool. That's quite a move. I mean, that's probably the furthest move you can make, right? From Northern California to I guess you could technically go from Miami to Alaska or something, but that's still a pretty far move.
Yeah, that's indeed. Yeah.
Cool. That's awesome. So, kind of for someone who has doesn't have a background in machine learning or in search and relevance, what actually happens when someone types in new shoes in Etsy and hits enter? What actually happens behind the scenes?
Yeah, that's a great question. So a lot of things happen back in the scene, and within that, I would say 100 milliseconds, we need to figure out how to present the best result for you. So I would vaguely, on a very high level, divide that into three phases. One is that we need to understand what is the user intent, or what do you really mean you type a query like wedding dress or new shoes. So that is the first one, what we call the query understanding or user intent understanding. So then with that understood, we need to go to our inventory. We have more than 16 million items in our inventory. So then we need to figure out how we can quickly boils down to around 1,000 items that seems promising from that inventory through search index. After that, we have around roughly 1,000-ish candidates, and then we apply sophisticated machine learning model to re-rank that according to many things. For instance, like how likely you are going to click on that, how likely you are going to buy that, and so forth, and mixing a lot of signals to get the best result. Let's say the best top 48 result, which is the first page. So then we apply additional kind of business rules or ideas. Say, hey, there are certain things are free shipping, or there's a certain things are in some promotion. So then we would like to pop them up further up. So then we will apply that. So then we present the final result to the users. So everything I just described should happen within a 100-ish kind of millisecond and really provide us a very speedy result to users.
Yeah, that's amazing. So going through that kind of line by line, so what do you mean by intent? So what are the different intents that someone has on something like Etsy?
Yeah, that's also a great question. So intent or current understanding, basically, I want to understand what are you really looking for, and like the users would like to use search for the things they have specific idea in mind. Oh, I want to buy a gift card for my mother. I want to purchase certain things for my wedding. All the way to a very vague kind of generic terms. Okay? So we need to understand, do they have a very strong shopping intent or shopping ideas such that we can help them quickly on their purchase path, or they are in some kind of discovery mode where they don't know exactly what they are looking for, but they have some vague ideas. So in that scenario, how we could help them in discovery mode as well. So shopping intent is a way we kind of categorize like how strong, how weak, like your intent or your ideas are, and so forth. We provide a different kind of mechanisms to surface different items and so forth.
Yeah, that makes sense. I think there's a huge difference between searching for something specific like iPhone 16 gigabyte versus putting something in like funny. If you put in funny, you don't really want something with funny in the title. I mean, that's not the requirement.
Right.
How do you know that? So in other words, how can you tell, like what sort of happens maybe in advance? Like what sort of processing can you do to figure out, okay, these words correspond to something very specific, and these other words are just abstractions or generalities?
Yeah, that's probably the core of the challenge of e-commerce search in general. I mean, Etsy is definitely specifically, one such example. So like comparing to generic search, like, generic web search, especially specifically like, Google, Bing, or even in the past, Yahoo, where I worked, in the past. E-commerce search, there's a tremendous of ambiguity, and also in terms of also personalization in terms of that, right? So like, there is no kind of a standard, ground truth of relevance, so to speak. So a lot of things we are trying to figure out is what the people are looking for, and what kind of thing they would like to buy now, what kind of thing they would like to buy, in 6 months down the line, and how do we define relevance, quote unquote relevance on top of that. So that is definitely one of the challenges that we are facing, and we're at in my opinion, we're at the very early stage. Etsy is part of that, but I think in general in the e-commerce search, if you try things in Amazon and others, you can easily see, the search experience is not there yet. Like, we are not at the stage we can easily figure out all these intents, in the current like technology framework.
Yeah, that makes sense. I mean, my guess is there would be just a very wide distribution over something like funny. So if someone puts in, iPhone 16 gigabyte, and I guess I'm using Amazon as an example here, they're going to look for exactly that iPhone. They're going to buy it, and the precision is going to be pretty high. But if someone puts funny, there's probably a huge distribution of content that people will visit based on that search. And from that, you can kind of guess that, okay, funny is one of these things that isn't tied to any particular product.
Yeah, so this is a great example, right? So like that would really differentiate, Etsy and versus Amazon to some degree, right? Because for Amazon, iPhone 64, gigabyte, or iPhone 11 Pro is kind of a standardized kind of commodity, if you wish. So there is a standard answer to that, and to some degree there's a one source of truth of the a wide range of the things Amazon is offering. On Etsy, however, right? So we are the global marketplace for unique goods. So there's a lot of things we can quantify as funny. There's a lot of things you can quantify as could be appropriate for gift for your mother. So there is no standard answer. So there's or at least very hard to say there is a standard answer. So we heavily rely on user data, user behavior, and figure out what is a good thing you might be looking for, and what is a thing that you feel you don't have interest for the moment. So that is one of the challenge we have versus Amazon's kind of commodity e-commerce search.
Yeah, that makes sense. So in this case, we figured out the intent. Let's say the person has some specific shopping intent, and they've put in a couple of keywords, but it's not something so specific we can just take them right to that iPhone. It's something like heart pendant for mom or something like that. And then you said the next step is you take your inventory of, I think, 17 million, and you narrow it down to 1,000 candidates. How does that actually work, and what is that process like?
Yeah, so we take the item and we take the query, right? So then we translate to some intent. Then we match those things with, in our search index. In a very, very naive way, you can think, at least we match with, query, okay, funny, or like we figured, okay, funny, which during period of time of, let's say, Christmas time period. So then we also send Christmas funny into the backend. So then we match things related to Christmas and related to funny. So basically, we have an inverted index that we could match these terms or these kind of intent, if you wish, or categories. And then we have some very rudimentary scores that basically representing how likely or how popular or how interested these items are. So then we sort them and we pick the top, let's say 1,000. Then we return to the second phase.
Got it. So could you describe, for folks who have never taken, say, a database class, we have plenty of thousands of people listening who are high school students or just starting college. What is an inverted index, and how does that let you go through all 17 million of these items in less than 100 milliseconds?
Yeah, that's a great question. So inverted index, basically you can think that is like, you have the keys as, in a very naive, simplistic word are our terms, right? So like funny is one term, Christmas is another term. So we build these keys, and then we associate each key with a list of product listings. In our case, like each listing, each item is each item ID is one such kind of value, right? So then we say, hey, funny term, item ID 260, 40s, and blah blah, so on and so forth. These 2 million items have contain term funny, so then we associate these items with that key, and then we apply certain mechanism to sort that, and we say, hey, for this funny term, for all the items, there are certain items seems more important than the others. So then we build this key value kind of pair associations. And we build for all the terms, all the intents, all the categories. So then you can imagine it's a huge kind of a key value kind of mapping. And then when we do the retrieval, we basically go to the keys and say, okay, how many keys we're going to hit, and then we get back the top items for each key. Then we blend them, right? We mix them together, and then we say, hey, we want to apply this popularity or interest score, and then we rank that. So that's basically like very, very high level describing how the inverted index works.
Got it. So the idea is like so someone types in, funny shoes for mom and funny shoes and mom. They all are in this database with a set of documents that are more or less relevant to each of those words. And then what you could do is you can take the union of all of these documents and then combine the scores in some way where you can kind of crush it down into one score. So if there was a document that had funny shoes and mom in it, then you could add up all those scores, or in some way you could combine the scores. If there's a document that only had mom in it, maybe it wouldn't score as highly because it didn't have the other ones.
Yeah, to some degree, yes. That's pretty much on a very high level what happens.
Cool, that makes sense. Is there any are you doing any work with embeddings or anything like that to handle, like for example, someone types shoes and maybe there's this product, but it's boots, but then you could use some sort of mathematical embedding, some vector space where shoes and boots are really close together.
Yeah, this is an area that we are actively investigating, and earlier this year, we published a paper regarding we apply, embedding techniques and building the similarity, trying to understand the similarities between items. And exactly like you say, there are certain things, you don't know exactly the keywords, but they more or less correspond to the same concepts or same kind of, the intent. So then we utilize embedding techniques to smooth out the items, such that even though you don't have exactly matching, we still get items that are possibly relevant to the query. So this is one area that we are also keep the very active eye on how to utilize this further in our search stats.
Cool, that makes sense. So then these 1,000 items, I guess now you have the resources to say, let's do a lot more work with these 1,000 items that we couldn't do with the 17 million. And that's where, as you said, all of this sort of business logic comes in. So you have these sort of hypothetical, you have these models that generate hypotheticals, like, will the person, I believe you said, will the person buy it? Will they click on it? But then how do you sort of take, this thing is highly multimodal, right? So someone can do all these different things. They might spend a lot of time looking at something, and they might spend a little bit of time, but then buy it. How do you, at the end of the day, sort when there's so many different things that have value?
Yeah, that's a great question, and also it's another core of the challenges of e-commerce search or e-commerce AI in general. So I think this question has two layers. One is short term and long, the other is long term. So short term wise, we have at least for Etsy, we have a business goal or business metrics we would like to drive for our product. I mean, a lot of our product, including search, which is called generalized merchandise value (GMV), and also for revenue for advertising as well. So we basically use that as a north star to kind of guide us, what kind of a model we need to build, and what kind of in your terminology, what sorting mechanism we need to apply, and we also use that as a guidance for us to derive machine learning pipelines and evaluation kind of a framework. So you can think that how to sort, how to weigh, let's say, clicks a little bit more, favorite a little bit more, how to weigh that you don't click anything, you spend how much time on the site. All these are the parameters. And we are seeking, ideally, the optimal parameter setting such that we optimize this, our North Star metric, which is GMV, or GM, the generalized merchandise value. Mm-hmm. And then we launch A/B testing, right? So we're launching A/B testing, and we measure the model on real traffic, on real users, and then we see, oh, this model indeed, outperform the control, which is maybe using the older version of the model, or maybe not, sometimes not using model at all. And then, there's a real difference from the A/B testing. Say, hey, within these 2 weeks of time we do the A/B testing, let's say there's a $1 million or $2 million. These are real dollars, the difference between the control environment. So then we could conclude, say, hey, we are, whatever this parameter set up, right? So we kind of figure out through some mechanism are really doing good in terms of our North Star, the metric. So this is a short-term kind of things we're doing, and we apply this across the board for our search, for our recommendation, and so forth. But then, of course, there's one more challenge thing, because we could say, sure, this sounds reasonable, but there are customers come to Etsy, they just want to do discovery. They may not, purchase anything within this 2 weeks of period of time. Are they still contributing to the business goal? How do we evaluate?
Yeah, I was actually just thinking that, if you do a 2-week experiment, everyone who comes to Etsy at least once every 2 weeks will be represented. But of the people who come, if someone comes once every 4 weeks, there's a 50-50 chance they won't even be in the data set.
Right. So that is one of the challenge, which is, okay, so we need to figure out the long-term value. Long-term meaning longer than A/B testing time period. Or so what's the value of that? That's usually we call long-term customer value, LTV, in some sense, that we need to assess and investigate what is the impact of our algorithms with LTV. Sometimes longer than 2 weeks, or sometimes 6 months, or even sometimes we want to understand for 1 year, in very long term, what is the value and how can we even optimizing our model towards long-term value. So that is more larger challenges and more in a work in progress, I would say. But in a very high level, we figure out for the short term kind of in terms of launching experiments, in terms of guiding machine learning models, utilizing GMV as a target.
Yeah, that makes sense. Yeah, I think that the long-term value stuff is fascinating, because it almost has to be counterfactual. In other words, either that or you need to have experiments that run for an extremely long time to really see, okay, I made this change and it affected the long-term value in this way. You either have to wait a long time, or you have to do some really clever analysis.
Yeah, that's a great point. And in fact, we're thinking about that. So we are indeed running some of the longer experiments to measure the impact of a lot of the things, we roll out, and especially aggregatively, right? So we roll out one thing this week and then another thing next week, and each of them have A/B tests, but do they aggregate, add up to the overall impact and so forth? So we are doing a lot of long-term experiments. But of course, we need analysis as well, right? Because certain things we cannot really run experiments for, so for instance, running for years, running for multiple quarters, or there are certain things, there are business requirements, certain, and etc. We couldn't be able to run experiments. So then, sure, we need to do a lot of counterfactual, observation study style type of investigation to measure the impact.
Cool. Yes, it's really fascinating. So now we do the ranking, and then I guess at that point the ranking, the ranked list of items goes back to whoever requested it. So I guess this would be it would be a web request that it would go to. Actually, it would probably go to some other server, I guess, that would handle the front end traffic.
Yeah, so like, so we can sort of conceptualize this as a front end, as a like PHP layer, or iOS or Android or apps, sending that thing to a backend server, and then within this backend server, we synthesize and combine a result from the inverted index I just mentioned. And then we apply all this, ML algorithm to optimize GMV, if we wish. So then we also apply additional business rules, as I mentioned, like, hey, we want to maybe promote free shipping, items. We want to promote other sort of items that our kind of, let's say, marketing campaigns want to show. So then those results would return to the front-end layer like PHP or iOS and certain thing. Then they will rent those results in whatever the format they need to rent.
Got it. Yeah, we just had Andy and Dave from the Pragmatic Programmer on the show on the past episode, and one of the things they were suggesting for engineers is they're saying if you only know one language, or if your whole job is just one language, learn another language. That was one of their big suggestions. And it sounds like, from what you've described, that this even if we take away the app and the website design, that even this back-end process involves many different languages and technologies.
Absolutely. So there is a variety of things we're using here at Etsy. I mean, similar to some other tech companies as well, right? So we have offline, processing, where we, generating ideas, validating ideas, and trying to write the machine learning algorithms and so on and so forth. So there we utilize like Hadoop style technologies, including Spark, and we also we are on Google Cloud, so we're also heavily utilizing a lot of offerings from Google as well. And then we have the servers, right? So the server, inverted index, and whatever this backend server I mentioned. There we use Java, we use Scala, and other languages as well to to write efficient code such that things can return within 100 millisecond. And then other times when we do like the data analysis, for example, as we talk about like counterfactual analysis, we have data scientists who use RStudio, Python to do a lot of other data processing as well. So there is a variety of tools and languages that the teams are using to get it productive.
Cool. What is the skill that you feel is most lacking? It doesn't have to be a language, but for folks out there who are in college and what is something that the universities aren't teaching per se, or something where you find it's kind of something that people should pay more attention to?
Right. That's a very good topic, and I think in general, currently a lot of universities, and by the way, I occasionally talk to university here at New York City, like Columbia University, New York University. They are offering bachelor program or master level program in data science machine learning. So I have a lot of contacts and and interactions with faculties and with prospect students and so forth. I think currently a lot of these programs, a lot of these degrees offering, I think on the skill level, right, so in terms of languages or in terms of tools are really kind of getting up to speed, right? So if you want to know, let's say Python, if you want to know, let's say NumPy, SciPy, or some of the TensorFlow, right? So like all these tools, okay, you can get the training and programs easily, with a sufficient kind of understanding of those tools. I think one of the challenge for the moment is that applying machine learning, applying AI to a lot of product domains require deep understanding of that product domain, like a business case, a business use case, as well as you're looking into everything from end-to-end perspective, right? So like we just talked about, okay, query coming, I need to understand the query, I need to understand how to get the things from the index, I even need to understand what inverted indexes are, and now I need to understand why we need to rank things according to GMV, not according to, let's say, the click-through rate or some other things. So understanding that holistic business kind of a scenario, and also start to develop ideas, to develop intuitions into that, I think we still require tremendous of training and really, get hands-on, into those problems and work on those things. So roughly speaking, we have a couple of master level and PhD, even PhD level, really good, graduates join our teams in the past, 2 years. Roughly speaking, they get up to speed after, at least 6 to 10 months, if not even longer, really being able to, get productive in the field. So I think the most lacking in terms of education piece is where, this gap or, where the students could get more hands-on in a lot of real-world problems, but at the same time studying those tools.
Yeah, I totally agree. I think the reasoning is always the part that seems to be left off the table. Like, for example, you see so many of these machine learning boot camps, and what they'll do is they'll give you a set of images, and they'll walk you through in TensorFlow how to say whether this is a cat or a dog, right? But then what you end up with is this model that predicts, probability of cat, probability of dog, but you don't actually do anything with it. So for example, I mean, this is a bit of a contrived example, but if you mislabeled in one direction, like you said it was a cat and it was a dog, let's say hypothetically nobody really cared that much. But if you mislabeled in the other direction, people just stopped using Etsy. Well then that massively changes, the decisions that you should make based on those probabilities. So even if you think it's a 1% chance it's a dog, if you say dog and you're wrong, and that has huge ramifications, then even 99% isn't good enough, right? On the flip side, if someone is, let's say, in discovery mode, maybe you want to show things that you're not confident about, almost on purpose, because you want to learn more. And so, actually doing things with the machine learning models and reacting to what happens, that's the part that I feel is completely left out.
Yeah, I absolutely, I think I agree with you. I think here at Etsy, we use machine learning and think machine learning are not kind of a code block technologies. We know that they are they have real world impact, right? So like recommendations, search results are really presented to millions and millions of our customers, and they are using those results to determine, what gifts they are going to buy for their parents, what things they get for their anniversaries, and so forth. So the better recommendation result definitely would drive those users away and also have a very real business impact. So like those things are not just 1% or 2% numbers in terms of accuracy or precision. So we look, we constantly looking into how are we really evaluating our results, not just talking about the accuracy level, but actually are people satisfying, are people really return to Etsy because of we provide more relevant results and so forth.
Yeah, that makes sense. So diving into the machine learning, so there's that part you mentioned where you've narrowed it down to about 1,000 candidates, and you want to know, let's say, the probability someone's going to, let's say, click on one of these candidates. Like, how do you actually know that? So, I mean, kind of what goes into the model? How is the model, created?
Yeah, so that's that's definitely the challenge, or one of the many challenges. So in a nutshell, right, we can think we need to formulate it in a machine learning kind of the concept of a supervised learning problem. By supervised, we mean that we have a target or a metric. Then we want to use that target or metric to guide our, model training or guide our model learning process, such that we optimize, in our case, maximize certain things. Right? Now, in our case, the target I just mentioned earlier, we can think that is a form of GMV, or how much money you can, very simplistic way, you can think that is how much money we are going to gain. That is our target, and then we say we form attributes or features for each of our items, right? So then we gather information like, in the past, how many people are clicking on this thing? In the past, how many people are purchasing this thing? And how, these people are from which region, right? So, what is the context? What time of day or what week of the month? Is this a Christmas season or not, right? So there's a lot of information from historically how good, how bad, this item performing, from, tax information that this item has, like title, description, reviews, and so on and so forth, from, many other data sources as much as possible we could together, and we form what we call these attributes and features. And we are gathering literally millions and millions of these attributes. And then after gathering these attributes, and then we have our target, like, the GMV or the money. Then we give these, two sides of the problem, right? So features or attributes, that's one side. And the other side is, target to generic machine learning, algorithms, things like, logistic regression, decision trees, deep learning models, and so on and so forth. And let the model trying to figure out what is the best, the mechanism such that we can associate, features with the target. Then we learn the model, to get the model out of those learning algorithms. So this is on a very, very high level how we figure out, to rank things, to optimize our business metric.
Cool. That makes sense. What about, how do you sort of capture somebody's, style? Like, for example, if I like blue shirts, or let's say I don't like shirts with buttons, which is actually kind of true. I almost never try to wear things with buttons because I feel like I'll become a product manager if I wear too many shirts with buttons.
Okay.
How do you sort of capture, there's so many different contexts, so many different aspects to someone's style, and the information you have is kind of what they've looked at. How can you sort of compose all of that to figure out someone's style, so that next time someone types in blue shirt, they get the polo?
Right. So, we need to understand, right, for each item, what styles or what kind of styles each item is belong to. So that is, step one. So there we, have machine learning, experts from my team, and we also partner with, domain experts inside Etsy. So then we come up 43 kind of styles to categorize all the listings, all the items here at Etsy. So then we develop basically classifiers, machine learning classifiers that we can classify, one of our 60 million items into those 43 styles. Right? So then each listing you could think belong to this space of styles, and this might be 80% to more mid-century modern, and that another thing belong to another styles. So we first get this information. Then we need to understand user preference, right? So as a user come to the site, depending on their past behaviors, what is the distribution? What is the preference distribution over these styles? Okay, each user would have a distribution over styles now. So after these two steps, right? So we get the style, kind of this category for each item. We get a style profile preferences for each user.
Wait, can you dive into a little bit on that second part? I'm not totally clear on how do you know do you ask the users like a survey or?
Well, in our current, way, we basically look at what kind of styles, things you clicked, you purchased, you searched.
Oh, I see. Oh, that makes sense. Yeah.
Then we aggregate that, right? We build a model on top of that. We do the profiling, and then we get the user, preference over that. And then the third step, which is basically matching your, profile versus this, database of all the styles, or, all the items with styles. So then we, match that, right? So then we get, let's say, oh, these are top 100 scenes matching your, past style kind of behaviors in the past. Then we, further apply, all the, mechanics that I mentioned. Okay, but within this 100, right? Which one, you would like to purchase, most, and so on and so forth. So then we, apply those things again. So that's basically the very high level of process, how to apply style.
Cool. Yeah, that totally makes sense. And then that has to somehow make its way back into that reverse index, so that you can index on the styles.
Yes, exactly, right. So like all these are additional information, we get, to help us understand user behaviors, because user behavior is very, very complex. Like, there might be certain users always like stick to their styles, but there are certain users, right? So like they buy gifts for their friends. They may not, look for things for themselves. So
that's true.
Yeah, so there are a lot of variations. So like how to understand users and how to understand like all the behaviors is very complex.
Yeah, that's really fascinating. It's funny. Netflix. I don't know how this came to my mind, but Netflix is very explicit. It says, "Hey, who's watching the Netflix right now?" And so if my son is watching, he knows to switch over to his name. But for something like this, it's there's still that multimodality, but it's not explicit. So Etsy doesn't pop up and say, "Hey, are you shopping for yourself?" You have to kind of figure that out based on what the person is doing.
Yeah, right. So like hypothetically, we would love to have customer telling us like, what mission they are on, and how we could help. But like we're in a much more implicit way, right? So like we have to figure out from user like how they interact with the site, and then a lot of contextual information we get, and trying to guess, or try to best guess like what is your intent, and how to do that. So it's a very, very big challenge.
Yeah, this sounds like an enormous effort. I mean, I don't know if feel free to be really rough with these numbers, but like roughly, like how many people are involved in this effort, and what's the growth trajectory been like, and like how are you expecting this team to grow? It seems like it's a huge effort.
Yeah, that's also a great question. So when I joined Etsy like in 2016, we had roughly 5 folks working in like machine learning kind of a space, including
5 very busy people.
Yeah, very, very busy. So we grew from there, right? So right now we're in between 30 and 40, and of course, like we're going to grow more. But having said that, I want to emphasize is that We probably are not going to do something like big companies where solving problems is basically scaling up teams, right? So like hiring hundreds of machine learning engineers, data scientists to figure out every single problems. So we probably are not on that trajectory. Um, which also opened up the door where we could look at things holistically and come up with better technical solutions, right? So for instance, we are the same. We are as a single team trying to figure out how to provide the best result for search desktop, search mobile, search in app. I do know that in some of the other companies, these are different teams. Now, in our case, we are the same team. So we have the opportunity to provide a model or framework such that could work the best in three different, contexts, but without like saying, scaling up the team, right? So like each individual could work on more technical challenging problems, similar to our recommendation problems. Like we have more than 50 pages modules require recommendations, right? But like we do not have that number of people. Versus some companies, each team working on one page, one module, we have the opportunity to work out a framework such that, let's say one model or one type of model could power multiple modules and power multiple pages. So that's where we would like to, really use technology, use innovations to scale up the opportunity to really, meet the needs.
Yeah, that makes sense. I think another part of it, which you mentioned earlier, is that you're using the like Google Cloud, and it was similar. I believe Netflix uses AWS. But, a lot of the a lot of companies are relying on cloud services, and I think from the purpose of someone who's looking for a career, it really encourages people again to just try and be polymaths. Right. So if you have to build the entire cluster from the ground up and on day one you're trying to write a distributed file system, then you need, as you said, just a huge army of people. And you could be the, distributed file system person who's writing, C, message, 0MQ code all day. But at Etsy, if you have 30 people handling all of search, then every one of those people, each one of those people needs to be a true polymath. And that's something where, again, just learning a lot of languages, learning a lot of technologies, and probably trying to build one of these systems. I mean, if you're running on the cloud, then anybody out there listening could also build something like this on the cloud, and kind of play around with it.
Mm-hmm. Yeah, absolutely.
Cool. So what is next? Like, there's, AI, machine learning, obviously still hot topics. I don't know if I really don't think we're at peak machine learning, although it's really, really high up there. We might be peak big data, but there's still a lot of ground to cover on machine learning. What is Etsy doing, in the future? What are some really cool search ideas that we should see coming out?
Yeah, so I think, I agree with you. I think we're, as I mentioned earlier, right? So in the multiple fronts, we're in a very early stage. Not only us, like I also believe ML or AI for e-commerce, also a very early stage. So we definitely need to keep investing in search, search in a narrow kind of context, meaning like we discussed primarily, in today's program, where you type of keywords. Let's say we want to provide the most relevant or most promising results you would like to buy quickly. So that's kind of a narrow sense of the search. So we definitely need to keep doing that and providing better service on that. But I want to highlight there is also a equivalent, more or less equivalent, amount of effort we are seeking is discovery, right? So we briefly talk about that a little bit. It's like, okay, I don't know what to, what to look after, and I don't even have a query in my head. But I like to, come to Etsy and browse a little bit and then, go from page to page. How can I, discover my needs, right? So like, such kind of thing.
Oh, interesting. Can you dive into that a little bit from the UI experience? Like what does that, is that just when people go to Etsy.com without a query?
Yeah, we definitely have a lot of people come to Etsy.com without a query. We have a homepage. There's a lot of modules and helping, right? So hey, these are the things you might be, might be interesting. These are the things from the shop you purchased in the past, and so forth, so and so forth. There's a lot of mechanisms we help you to discover new things, and there are a lot of other pages other than the search page serving the functionality of discovery and trying to speed up that process.
Yeah, if you have time, it'd be really interesting to dive into that. How do you sort of handle that where there's no, because now you still have that 17 million, was it 17 or 70 million?
60, sorry, 60, 60.
60, okay. So you have that 60 million sized inventory, and now you don't have any query. How are you able to still meet that SLA and get results quickly?
Right. That's another, like I mentioned, almost another half of our effort, which is what we call discovery or / recommendation, right? So basically, you can think recommendation is kind of the process without the query. Like, a lot of other, the companies and, apps are doing like the so-called queryless kind of a search queryless, like a push or recommendation. So there we heavily utilize your past behaviors, right? So they say, hey, you purchase the things from this shop, and it seems like there are similar things from the same shop. Are you, are you interested, right? So, and also you purchase the things in this style, and there are like other things seems, from the same style, also from similar kind of categories. Are you interested, right? So like we harvest heavily on your past behaviors to give you a recommendation, to guess what you are looking for without even asking you, without you providing a query, right? We also provide, kind of a recommendation when you do the browsing, right? You go to the listing page, and then on the listing page, there are modules showing other similar listings. Like sometimes it's similar from the same shop, meaning like same shop might offer other things you would like to buy, or like visually similar, right? So okay, so you are interested in this painting with a bear, and there are other paintings with a bear there. So how about you browse that a bit, right? So like we utilize that quite a bit, and they're trying to do the recommendation for you.
That makes sense. Yeah, I mean, bears are awesome. What about, how do you prevent, so let's say someone puts in bear, or let's take a step back. Let's say someone makes a bear, I don't know, coffee mug on Etsy, right? Mm-hmm. And so, maybe something more esoteric than, let's say hypothetically there isn't any bear content on Etsy. Someone makes the first bear mug. Someone types bear and they find that bear mug. And then that person kind of becomes the source of truth for bear. And then they end up with a lot of clicks. And then because they have a lot of clicks, they're the number one result. And then because they're the number one result, they have a lot of clicks. And there's this sort of like winner take all phenomena where now if I try to make my own bear mug, I can't compete with these people who have already been on the site for a long time.
Yeah, that's a really, really great question. So Etsy is a two-sided marketplace, right? So we have buyers, we have sellers. We constantly look into how to optimize. A lot of things we talk about today are primarily from a buyer perspective, but we do care very much about our sellers, right? So like whoever are entrepreneurs and these folks are making goods and then creating things, and offering for the buyers, and growing that audience is also very very important, and retain that audience is also very, very important. This is not an easy problem, right? So like in a lot of scenarios, yes, there might be a phenomenon of winner takes all because like the things you are selling are good, like you're performing very well, and there's a reason your things are performing very well, and the system kind of remember that and trying to promote same type of thing. But we also are very cautious of this kind of winner takes all kind of phenomenon, and trying to help boost new sellers or new items. In recommendations literature we call cold start, right? So we don't have data, but we cannot assume they're bad or they're like not performing. It's just now like nobody we haven't showed them before. So we are constantly testing different algorithms, ideas to come back with cold start and trying to promote new sellers and new items to accommodate this situation. But this is not an easy problem. Like how we serve the buyers, at the most most relevant way. At the same time, keep a very very viable marketplace such that everybody, or let's say a lot of folks in the seller side have a share. That's definitely one of the challenges.
Yeah, it seems as if it's very empirical, right? I mean, it's almost impossible to come up with some kind of closed form that will tell you how to trade off learning more about some new item versus showing the best thing you've ever seen. It seems like that it's always going to come down to some sort of empirical analysis.
Yeah, that's true. That's true. We also have other channels, right? So like sellers, if they are willing, they can participate in our promoted listing program. It's like a on-site advertising program where they could spend some budget to significantly boost their listings within our system. We do offer such opportunities, and in those scenarios, we also utilize machine learning in various places to determine how to best show your thing. So like if a lot of sellers, in fact, are utilizing our program to show their things and to boost their things through their reach and through of course, using some budget. So like we're definitely looking into like various of channels to accommodate the issue.
Yeah, that makes sense. It gets into some really deep sort of economic analysis that they would have to do, and I'm sure you would help them with. It's like if I show this advertisement for my product with the expected value of my campaign or my lifetime on Etsy go up. If so, then you'd spend the money on the advertisement to sort of build the brand, and it becomes this sort of short-term, long-term thing again.
Mm-hmm. Yeah, that's true.
Cool. So what about one thing I've noticed is there's a ton of companies getting on board with open source and with academia. I think even some companies are usually like pretty closed doors. They're starting to publish papers and do open source. What is Etsy's sort of, how do they feel about the whole open source thing and information sharing, and sort of what do you folks do there, and why do you do it?
Yeah, this is a good question. So if you look at GitHub, Etsy has repositories on GitHub and public available with a wide range of repositories there. And we have blog posts constantly publishing some of the interesting things, learnings, and experiences that our engineering teams, including like my teams, are having here at Etsy. And in terms of my team specifically, we go to a lot of different conferences, meetups, conferences including academic conferences, industry conferences, and we do talks, and we sometimes publish papers. We do presentations, and we have a very kind of open and a collaborative attitude, I would say, towards open source community, towards the tech community in general, to be part of that, to contribute and also facilitating a lot of things. I think in terms of the reasons, there are two major reasons I think are very important. One is like I mentioned, right? So machine learning or AI for e-commerce, I think it's a very early stage. The more people in general is interested in that, the better solutions in terms of technology, in terms of the solutions we are building can build on larger communities, right? So recommendation kind of system community only exists after Netflix competition, almost like 10 years ago, and also people get excited about deep learning and so forth. Well, because AlphaGo kind of a related thing published from DeepMind from Google. So there's a larger impact of getting evolving a community and being able to talk about the technical solutions and get excited about that. So that is one. Second is, of course, the hiring and getting talents are super critical for us to work on those exciting problems. When we go out and talk to candidates, they value we are part of the larger community, and they also value that we could talk about a lot of things like today we discussed. Now, if we say, hey, everything just proprietary, we can't talk, then it's very unlikely we can, really stir the interest from our candidates. So, by really being, open enough and being kind of play a big role, or trying to play some even bigger role in this community, would help us to establish reputation and would help us to attract the top talent.
Yeah, that makes sense. I think I saw something recently that said one of the best things someone can do from their career is to build sort of a personal brand. And when you look at academics, they could go into university and become a professor, and they'll have extremely strong personal brand. They'll teach the courses under their own name. They'll write papers under their own name. And so if industries such as Etsy keep everything closed off, then someone will say, well, why would I not go into academia where I can represent myself? And so, yeah, I think it's hugely important. What speaking of hiring folks from academia, what sort of positions do you have? Where what are the offices where there are search folks, and are you guys hiring? What kind of roles?
Yeah. So we're, like I mentioned a little bit earlier, right? So we are growing and we are hiring data scientists and machine learning engineers, both here at New York City office as well as our San Francisco office. So we have constant openings in these two offices, and in general, Etsy Engineering, hiring in these two offices as well as Toronto office, and we have Dublin office as well. So we are
cool.
Growing in these couple of different locations. In terms of roles, we are generally hiring folks with machine learning background, and we vaguely kind of divided into two kind of type of roles. One is called data scientists, and the other is called machine learning engineers. Basically, we are looking for folks with a lot of, modeling background, really interested in pushing the, last couple miles of our, model performance, and thinking about the new methodologies, thinking about the new ideas, as a data scientist. And we would like somebody with a very strong system level engineering, design, as well as pretty much equally understanding of machine learning to help us build offline pipelines, serving systems, as we mentioned, as this backend as machine learning engineers. So these are the two, like, on very high level, two kind of the roles that we're hiring in Brooklyn, New York City office, and San Francisco office.
Cool. So one question we get a lot is from people who they want to know how to best get one of these jobs, right? So they might have got a degree in, let's say, petroleum engineering, and so they're coming to programming for the first time. They might even have a very strong mathematical background, but maybe not a programming background. And the questions we get are, should I go back and get another 4-year degree? Should I do the Coursera or Udacity or these other MOOCs and get sort of some of these nano degrees? Should I jump into one of these in-person boot camps? What's your feeling there? I mean, obviously, for some of these very mathematically oriented roles, having let's say a PhD in math or in computer science would be preferred. But what are sort of like, other ways that people can sort of get those skills?
Yeah, that's a great question. And I think some part of this also echoes, a little bit earlier discussion on the, on some of the master programs and the bachelor programs. So in general, I would say there is no one answer to everybody. So one thing I want to mention that we currently in our teams, we have a very diverse background. Like, these 30-ish people, half of folks have PhD degrees, half of folks have master degrees. And if we look at their backgrounds, we have folks, of course, from computer science, but we also have folks from electrical engineering, operational research, statistics, economics, physics. Like, we have actually a pretty wide diversity in terms of the backgrounds and where their degrees coming from. So that's why I would say, like, there's no one short answer. And from interviews, we are actually interviewing a pretty wide net because we would like to be inclusive and trying to find the best people, not just looking at your resume, like a one line of application. So we actually interview like political science, nuclear, physics, you name it, like to astrophysics, like a lot of different kind of education background. So the current situation is like we talked about it earlier, right? So it's hard to say, the best shot is just go back to your master program or just do this 12-week intense training, because after that, each person still differs because of their individual's kind of experience. So I would say, in general, is like if we really want to, give some advice to individuals, we tend to say just look at your own experience, and then we can think about where you are in 3 to 5 years and really start to think about the path, to that. Right? So hey, I'm just a software engineer without machine learning background, but I'm really interested in that. Okay, so if my goal is to grow into a hardcore machine learning engineer in 3 to 5 years, here are the steps I might take, right? Or I say I have zero even coding background, but I'm strong in math. Like I have a math degree. I want to be this kind of person to do some applied research. Okay, so in the 3 to 5 years time frame, what are the steps I could take? So I think that step, fortunately or unfortunately, currently has to be kind of personalized. So then each person can take their own path.
Yeah, that totally makes sense. Cool. What is, if someone interviews, what is that experience like?
Yeah. So we have a kind of a standardized interview process, which very, very similar to, most of the typical kind of tech companies. So we have 2 rounds of phone interviews. The first One is to test whether you have some basic coding kind of, background, not necessarily, solving, kind of coding puzzles, but like, hey, do you understand data structure? Do you understand, for loop and, many kind of basic ideas. The second phone interview, we tend to look at whether you understand machine learning basics, right? Because believe it or not, in the current hype of AI and machine learning, there's a huge amount of people sort of understand deep learning, but they don't understand logistic regression. They don't know what supervised learning are. They don't understand, linear regression. So we go to the basic, and then we're asking like textbook level kind of a concept. Okay, do you understand this thing? So that is our second, phone screen. After 2 rounds of phone screens, we bring people on site, right? So in the on-site interviews, we have a couple of slots. We have, again, coding, whiteboard-ish coding kind of a slot, basically, typical coding questions. And then we have so-called applied machine learning kind of a slot. So basically, we present you a real-world problem, kind of abstract a little bit from Etsy's real-world business. And then we say, okay, here's a scenario, right? Imagine that, you work with a product manager, and this is things that the product manager come up. You, as a new member in data science team, want to figure out what is the solution. How do you present the solution, right? So how do you think about this problem? So then in that 60 minutes kind of a slot, the candidate would walk through a solution with our data scientists in the team. So we have 2 such sessions. Then we also have a system design slot. So basically, we look at, okay, great. So you have this idea, right? But how can we get the result back within 100 milliseconds, right? So like which process you need to do online, which process you need to do offline, like, you need to cache things somewhere, like where do you store those things, and so forth. Like, can you draw a very simple system diagram to talk about the things you just mentioned? So we have one such session as well. So then, this is our kind of a typical, on-site kind of interview process. So then we have 2 rounds of phone screen and a couple of slots on-site interviews.
Very cool. Yeah, I think, just to recap some of the things we said earlier, trying to actually build these things by yourself, I think, is one of the best ways to get prepared for an interview like this. Now, of course, not all of us have a site with 60 million items in it or anything like that. I mean, it could be just a bunch of synthetic data. But all of these are problems that people could experience in simulation right now. So someone could create a set of 60 million set of random vectors and then try to find the nearest neighbor and realize that they need to build some data structures and things like that. Obviously, the kind of courses and things you can find on the internet will help as well. But yeah, it sounds like getting some hands-on experience is something that could really help people.
Yeah, that's actually one thing I actually mentioned to some candidates when we talk, because I just ask a very similar questions. We started this program, which is like can you imagine a process, right? You have to type the keyword to Amazon, to Etsy. How do we get the result back, right? So that's a mind exercise, like a thought exercise. How do you do that, and how do you break down the system? How do you talk about each component? And several candidates will say, "Wow, yeah, I never thought about like that. Like we never really try to reason about that, right? So and in fact, you could do that thought exercise to a lot of things, right? So like imagine how to do that for the scale of Amazon, or do recommendation in the scale of Netflix or Google search, right? So like how do you propose a system, or how do you think about that? I think building some cases and exercise some thought exercise, and also like you mentioned, right? So generating some synthetic data play around are really good steps to get some intuitions into these domains.
Yeah, absolutely. Totally agree. So the Etsy blog, there's an Etsy machine learning blog, correct?
We do not have a separate one for the moment.
Oh,
We have
it's
a
part of the engineering blog.
yes.
Got it. Okay, cool. So that's I'll search that up and put a link in the show notes. Cool. And you're on Twitter. It's Hong Liangjie on Twitter,
Yes.
right? And
Yes.
we'll put a link to that also in the notes.
Okay.
Cool. This was super interesting. I think this is one of those things that Google is probably one of the first things that people do when they get a computer. Today, I mean, when I got my first computer, I didn't have internet, but today that's probably one of the first things people do is search, right? And so it just seems kind of for many people just magical that they type things into Etsy and get results. It seems like there might even be. I mean, there's probably people who think that there's some human in the loop, just because it is one of these things that it's just so incredibly remarkable how you can search through so much content so quickly. And I think you did an amazing job of kind of breaking it down into those components. Talking about like the sublinear ranking, the reverse indexing, and all of that. I really hope that people and believe that people at the end of this have kind of now a holistic understanding. And now if they want to deep dive into any of these topics, like, if they want to find out like what it actually is a reverse index, how can I code one myself? They have all of the right terminology and they have the right mental model to really dive deep on these topics. So I really appreciate you coming on and explaining a lot of this to people. And it's been really exciting. I've learned a lot about Etsy and their processes and how the whole thing is organized.
Yeah, sure. So absolutely. So I also feel this is a really great opportunity for us to explain how Etsy search works and also lay out the challenges we have and talking about a lot of interesting things we're working on and how we could move forward. So I also appreciate the opportunity to chat with you too.
Cool. One last question: are there internship opportunities, or is it only full time?
Yes, we do have interns. So last couple of years, we have interns coming here working on projects, and people get excited about that. So we are hiring interns. Actually, just go to our career page. So we are hiring interns in the same location, New York City, and as well as a San Francisco office for data science interns.
Cool. So folks out there, if you're in university, this is an amazing opportunity. Definitely check it out. And thank you again, Liangjie, for coming on the show.
Thank you for having me here. Yeah, thank you.
Thank you.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.